Okay, good evening. Assalamu alaikum. So today is the third discussion for FWC paper. Actually, we should have finished this some days back, but I actually forgot about it because I thought I discussed all the questions and then, you know, happened like that. So anyway, these questions are a bit difficult, like I said previously, and we stopped at the 16th question, right? We found the answer for 16th question, which was third answer. And then we have to discuss 17th question. Okay. 17th question is about vibrations in tubes. So in A, they give you one enclosed tube. So they say the fundamental frequency of particles vibrating in one enclosed tube A is 100 Hertz. If this tube is cut into two equal pieces, so you know the length will be half. BC, what are the first overtone frequencies created in B and C? So you should know the equations for each and every overtone. So initially they talk about fundamental overtone. Okay, fundamental frequency in the first. Okay, so it's like this. So fundamental overtone will look like this. Okay, so now we are going to ignore the end corrections. Okay, so here and there will be errors here. We are going to just neglect that, and let's take the length of this tube as L. Okay, if the velocity of a sound wave in air is v, what is the equation here for fundamental frequency? So you know what that is here is only half of a loop. Okay, the complete loop will look like this. But what is this? This is only half. So then you can say it's only 1/4 of a wavelength. Okay, if wavelength is lambda naught by 4 will be L.
Got
Yeah, what? Yeah, any questions? Okay, that's all right. So lambda naught will be equal to 4L. Okay, so if I substitute that here, F naught will be equal to, according to V is equal to F lambda, F will be equal to V by lambda naught. So F naught will be equal to V upon 4L. Okay, so this is the expression for this that will give you, according to the question, 100 Hertz. All right. So now they have cut into two halves. So one looks like this, other one looks like this. So now you know only L by 2 is here. Only L by 2 length is here. So now they are talking about what? First overtones. Okay. So they are talking about first overtone. That is the problem here. You might draw it for fundamental and find the answer wrong, but it is first overtone. So first overtone will look like this, right? Here, first overtone will look like this. Okay. The fundamental for this will look like this. First overtone for this, both ends open tube will look like this. So this is the first overtone for this. This is the first overtone for this. So what is the, if it is L by 2, yeah, what is the equation for lambda here? Huh? Lambda 1. So a complete two loops will make a wavelength. Okay, a wavelength is this. Okay, now you have 3/4. Okay, so you divide it by 3 and multiply it by 4, you will get these two loops. So into L by 2. Okay, so here lambda will be equal to, you chop this, it will be 2L by 3 here. Okay, in this case, lambda 1 is equal to what? The wavelength of first overtone will be equal to what? The length itself, because already there are two complete loops. There is a complete wavelength here. Okay, so this half and this half will make a full loop, and this one will make 2 loops. So this will be equal to L by 2. Do you understand? So now you know the wavelengths. So now you can write equations for frequencies. Okay, so I'm going to name this one. They have already given B and C. So FB will be equal to V divided by lambda, right? So lambda will be 2 L by 3. 3 will go up. It will be like this. And FC will be V naught by lambda will be L by 2. Okay. Do you see? So this is V by 4L. So now you can relate these two and find the values. Okay. So what do you see? It has been multiplied by what? It has been multiplied by something like 3 into 2, right? 6. Then only you will get 3 by 2. So it is 600 hertz, because this is 100. When you multiply by 6, you get 600. And how do you get this? When you multiply this by 8, you get this, no? So 8 times this. So it will be 800 hertz. Okay. So the correct answer is third one. Do you have any questions? Students, is my voice clear and the whiteboard clear? Hello? You can just say yes in the chat if you don't want to talk. Okay. Thank you for your response. Let's move on to the next question. So this is your relative humidity part. This is kind of a confusing part if you don't understand it. Okay. So the question is, we are not going to discuss the theory extensively, just the question. Okay. Otherwise the time is not enough. It will take another discussion. So I discussed a little bit of theory also. Now the question number 18. Temperature of air inside a room of volume 1 meter cube. 1 meter cube. Okay, initially they say about a 1 meter cube, 1 meter cube room, which is at 30 degrees Celsius. And they say the relative humidity is RH, is 80%. 80%. Then they say when temperature is of the room becomes 20 degrees Celsius, room gets saturated. Okay, so why does it get saturated? Why do any room get saturated? When the temperature is less than the dew point, right? Somewhere there would have been a dew point, so it has got saturated. So when it saturates, what will be the RH? Come on. It will be 100%. Okay. So at this point, it would have become 100%. And they also say 50% of the condensed water is removed. There is a condensation also. When the room is not enough to hold that water vapor in that particular temperature, the maximum capacity will be there, but anything that exceeds that will undergo condensation. How do you decide how much was condensed? That is using the maximum H possible. Okay, so that is what you call saturated vapor, absolute humidity of the saturated vapor. So here it is given. Can you see that the absolute humidities of saturated vapor at 30 degree, 20 degree are 30 and 18 into 10 to the power minus 6. So usually when I teach, I call the absolute humidities of saturated vapor as absolute humidity of saturated, AHS. So here AHS at 30 degrees Celsius is given as 30 into 10 to the power minus 6 kilogram per meter cube. Okay, like that here, AHS is what at this temperature? That is 18 into 10 to the power minus 6 kilogram per meter cube. Okay, all right. So now, when you decrease the temperature, this will not reduce. Sorry, what I mean is there will be AH here, no? I mean AH is different from AHS. AHS is what that makes 100%. So what would be the AH here? Because RH, 80%. The saturated one is 30. So what is the AH here? What is 80% of 30? Yeah, I ask the question like that. What is the 80% of 30? Calculate and tell me. What is the 80% of 30? Come on. Should I do that? What? Your mic is unmuted. So can you tell me what is the 80% of 30? Rukaya? It's 24. Okay. When you decrease the temperature, the AH won't change. AH is the amount of water vapor that is there per unit volume. That will not change. That changes only when the condensation happens. Now you have reduced it to 20 degrees Celsius and they say it can contain only 18 into 10 to the power minus 6 per meter cube. Okay. So you are bringing 24 to this kind of environment. So this is the maximum that it can hold as vapor. Okay. So the rest of it will undergo condensation. Do you understand that? Okay. Rest of it will undergo condensation. So how much underwent condensation? Initially there was 24 into 10 to the power minus 6. Now it contains only 18 into 10 to the power minus 6. So what is the condensed amount now? Come on. Just 24 and now 18 is left as vapor. So what is the condensed one? The difference. Okay. So 6 into 10 to the power minus 6. The condensed, we can't say per meter cube. Okay. So here it is 1 meter cube now. So it is just kilograms. So this much kilos will be as water. So now you are removing 50%. Means you have removed, okay, I put a minus here. You have removed 3 into 10 to the power minus 6 kilograms. And what is left is, when you remove what is left is 3 into 10 to the power minus 6 kilograms. Okay. Do you understand that? Now, if the temperature of the gas is increased again till 30 degrees Celsius, what is the relative humidity of the room now? So now if you increase it again to 30 degrees Celsius, what will happen is at 20 only you can hold 18. Okay, at 20 you can hold only 18 as vapor. But now you are increasing the temperature. So this condensed one and that was not removed will be there, right? So this will also undergo vaporization and then that will also create the vapor to the final environment that we will going to create at 30 degrees Celsius again. Okay. So now initially at the room, sorry, in the atmosphere, there was 18. Now this will also vaporize and come. So now at 30 degrees Celsius, again, after undergoing all these, again coming to 30 degrees Celsius, what is the total amount of vapor? It's 18 and this 3, no, because 3 is removed. The 50% is removed. So then 3 is gone, another 3 will be there. So 18 plus 3, which is 21 into 10 to the power minus 6 kilograms, will be there in the room now. Okay. And you know, the AHS at this temperature, sorry, 30 degrees Celsius. So now they are asking you for the new RH. Okay, you know RH is equal to what? The AH, what that is there, divided by AH that is needed for saturation, multiplied by 100. What that is there is 21 into 10 to the power minus 6. What that is needed for saturation is 30. They have already given you that into 100. Now it says 70%. Okay, so that is the relative humidity. I would say this is a very good question. Okay, so the answer is second answer. The answer is second answer. Okay, Rukia has answered in the chat. Very good. 24. So this the answer is here. Okay, now we have only 6 questions to go. I think it's 7. Okay, 19th one. When the heat is supplied to water of mass capital M by heating a heating coil from time t is equal to 0, the time taken to raise the temperature by delta theta is T1. The water boils at T is equal to T2 and mass M vaporizes at time T is equal to T3. The ratio, so you have to note that the mass small m is different from the total mass. The total mass is given as capital M, but the mass that vaporizes is given as small m. Okay, so don't put both small m's or both capital m's and chalk. Okay, that is one mistake you will make, but that will give you a wrong answer, and that answer is not there in the answers. So you are safe. Then you have to spend more time. Okay, now at T3, small m mass is vaporized. So the ratio between specific heat capacity of water and latent heat of vaporization is. So what is specific heat capacity of water? That is the heat that is needed to increase the temperature by 1 degree Celsius for a unit mass. 1 degree Celsius or 1 Kelvin for a unit mass. What is latent heat? That is the amount of heat that is needed to vaporize, or for the change of the physical state. It can be vaporization, it can be melting, it can be condensation, it can be those things. Okay, it can be freezing. Okay, it per unit mass. Okay, here there is no temperature change. Okay, so it is just the heat per mass. That is a latent heat. Okay, so here you can see the capital M is heated. So now you are using the heater for time T1, aren't you? You are using the heater for time T1. So delta T, the time duration of use is T1. Let's say the power of the heater is P. So now the heat you are giving is P multiplied by T1. Okay, so this will give you the heat. Okay, the energy will be equal to power multiplied by power times time. Okay, because power is the energy per unit time. So this will be equal to the heat needed for the temperature difference, that is given as mc delta theta. Okay, they are telling for delta theta, it is taking this much time for this mass. So this is the equation for the heat needed. So C is the specific heat capacity. Okay, C is the specific heat capacity. Some people put S for that. That is also fine. Okay, don't worry about that. So you have one equation now with you, mc delta theta. Okay, yeah, so this will be named as equation 1. Okay, now they are giving another data with regard to the latent heat. So latent heat is the heat that is needed for vaporization. Latent heat of vaporization will be the amount of heat per unit volume. Sorry, unit mass. Okay, so if it is the latent heat L, that will be equal to the amount of heat required for unit mass to vaporize. Okay, that is a physical state change. So there will not be a temperature change during that process. The temperature will be used only to break the bonds and change the lattice. Okay, so for example, to break the bonds in a solid and then make it into a liquid lattice. Okay, or it can break the bonds of a gas. Sorry, can break the bonds of a liquid and make it into gas. Okay, those are two different types of lattice, right? So that bond breaking happens using the temperature. So no temperature change occurs. So now they tell you it starts to boil, okay, at T2, and when it is T3, mass M vaporizes. So the time duration of giving heat will be T3 minus T2. So during this duration, you have given the heat. Okay, so here you can apply the equation. Heat is equal to, we are making this a subject. So M will go to this side and it will be ML. All right. So the heat will be the power times the time duration of heat supply. So this is the point where it started to boil, and this is the point where the M has finished boiling, the mass small m. So that will be T3 minus T2. It's the duration of heat supply. That's why they specifically mentioned when it starts to boil. Okay, because the boiling never happens before the boiling point. Once it reaches the boiling point at T2, the process starts. Okay, you can show that in the graph. For example, you increase the temperature giving MC theta, the theta increases and it reaches the boiling point. After that, there will be a constant temperature. So this is the period where it gets all the latent heat needed and then it increases again because it has become gas and now the temperature of the gas will increase. Okay. Yeah, so this is the period that we are looking at. Starts boiling at T2 and finishes at T3. So the duration of heat supply is T3 minus T2. So this is the heat. And that will be equal to M into L. That's it. This will be the second equation. And you divide first equation by second equation or second equation by first equation. You will have the pace cancelled and your answer will be fourth answer. Okay. So you do that. The maths is up to you. Okay. You can do whatever the maths and find the answer as fourth one. Okay. Yes. Shall we move on to the next one? Are you all clear with this? Okay. Yeah, another complicated question from FWC. But we can't blame them because in final exam also they give. In 2020, they had a lot of rings and asked you to find the center of gravity. Here also there is a complicated sum. Only thing you need is the patience. Okay, now they say the radius is R. And figure shows a star portion has been removed from a uniform circular disk. So uniform means you should understand that each and every piece, you take a unit area here and at another point, the area, same area will be of same mass. That is what you mean by a uniform. Okay, so if it is uniform, the area will be directly proportional to the mass. Okay, so if you remove half of the area, then you are removing half of the mass because it's uniform. So that is the simple understanding they should have. And disk of radius R, the distance of the center of gravity of remaining part from the center. Okay, the distance of center of gravity. So they're asking for the distance. So some questions will be like this: identify the center of gravity among the given points. So there you have to like approximately find the movement of the center of gravity, shifting of the center of gravity, and give the point. So those questions will be like among first 10. But this question is the 20th question in a paper with 25 questions, right? Questions. So you can understand this question needs calculation. So what kind of theory that you can use here to find the exact point of center of gravity? What theory can you use? You can use the theory. You can use the theory of moments of forces. Moments of forces, the torque. You can say, so initially it was an intact disk, a beautiful disk. And the disk will have a mass. Now we have removed some mass, so now it has resulted in a resultant disk, okay, with a hole here. So this was the deficit that has occurred. So now you know, we can say, okay, we can say an intact disk minus this much area will be equal to this. Do you understand my point? Subtracting this from this will result in this. Does it make sense? It should make sense because we have removed this part and it is our outcome. So intact disk minus a square disk of this much area will be equal to this, right? So you can say the moments of forces also will follow the same theory. The moment due to this intact mass minus the moment due to this part, moment of force due to this part will be equal to the moment of this resultant object. Okay, which means the disk with a hole. Okay, I will explain it again. This minus this result in this, so we can talk the same thing for the moments. Moment of this, which means the moment due to weight. Okay, weight is the one that creates a moment. So moment due to this weight minus, because it's removed now, minus the moment due to this will be equal to the moment of this resultant object, the weight of this resultant object. So I'm going to take, this resultant object has center of gravity here. Why am I taking like this? Because the center of gravity shifts to the area where there is more mass. Here you have removed this mass, so it should go towards the part where there is mass. There is more mass. So this half has lots of mass, so it will move towards this half. Okay, it will be along the axis because the individual center of gravities will be in the same line. So the shifting will also occur in the same line. If you remove something here, it will go above. If you remove something here, it will go like this. Okay, but you are removing something that is having a center of gravity along the axis, that will be the same line, the shifting that will occur. Okay, now you know, if it was intact, it will be here. But that was removed, will have its center of gravity here. So we have 3 center of gravities. So now we are going to calculate the masses. Okay, so I told you, because it's uniform, mass is directly proportional to what? Mass is directly proportional to what? Fatima, mass is directly proportional to what? Area, isn't it? It's area. So I think you're answering in the chat. When I open chat, it goes like this. So now the mass of the big mass, let's say this is big mass, this is small m. So the outcome will be m minus m. So the big mass will be directly proportional to pi r square. Pi is given as 3, so 3r square. This one, we have to calculate the area. Okay, that's why it's FWC paper. So now you know this one is r by 2, right? Because it's a uniform, circular shape one. Sorry, not circular, square shaped one. So its center is here. So it will divide the r into 2. R by 2, r by 2. So if it is r by 2, this is also r by 2. You know the diagonals of a square equal and they bisect in the center. So this will be r by 2. Now what will be this then? Reduce your Pythagoras. So you know that will be r by 2 square root 2. Isn't it? Because this is the hypotenuse. So if you cut this, it will be r by square root 2. It will be r by square root 2. So now finding the area of this. Square, no? So r by square root 2 multiplied by r by square root 2. So now r squared by 2. Okay. So this m will be directly proportional to r squared by 2. Okay. So this is, can you see, 3r squared. This will be r squared by 2. So if I say that this mass is just m, I consider this mass as m. In terms of m, can we determine the mass of capital M? How many times bigger is the area of this than this? I mean, be area of this than this. You multiply it by 6, that will result in 3r squared. No? So you can say, if this is small m, this will be 6m. Now, when you come to this outcome disk with a hole, it has center of gravity here. The mass of that outcome disk will be 6m minus m. So it will be 5m. And 5mg, if I talk about the forces, this will be the intact disk, that will be 6mg. I'm drawing everything here. This will be mg. Okay. So now I told you the moment of this minus the moment of this will be equal to the moment of this. So you have to find the moments. Okay, you have to find the moments about some pre-decided point. You have to decide the point first. So for my convenience, I'm going to select this point. Okay, I'm going to select this point. Oh, why? Because I'm clever enough to avoid this. I can use this also. It's easy. Okay, but it's easy to take 6m because the distances will be x and this will be known distance r by 2. And I can avoid this mg because it's going through the same point I am taking the moments about. Okay, so I'm going to write the equation. So from here, the moments due to 6 mg, moments due to 6 mg minus the moment due to, I should take the moments about r no, so moment due to this mg will be moment due to 6 mg minus moment due to this mg into r by 2 will be equal to what? The moment due to this 5 mg. So let's say the distance is x into x into what? 5 mg, no? Okay. So this is the expression. Okay. One might take the points about the point this also. Then they will avoid the moments due to 5 mg. Okay. So they will be like 5 mg multiplied by 0 will be equal to 6 mg, and they will find the distance from here, which is x, minus mg into what? What is that? What is this distance? X plus r by 2. Both are correct. Okay, and this will come to this side and you will solve it. All right. But here the problem is, here I have taken this will be in the clockwise direction, this will be in the anti-clockwise direction. So one will carry a minus. But our discussion is not about plus minus. Okay, our discussion is about just to find the value of x. So mg gone. Okay, so x will be equal to, if you take this 5 to this side, it will be r by 10. Here also you will get the same answer. Here the moments are in the same direction, so you won't get a negative sign. Okay, so it will exactly give you r by 10. Okay. Do you understand? So the point that you should write down is the moment of initial object, intact object, minus moment of the removed part will be equal to the moment of the outcome object. Okay. If you're adding something, for example, if you are connecting another thing like this, the moment of the previous one and the moment of this added together will be equal to the moment of the resultant. Okay. But here you are removing, so you subtract. Okay, 21st question. Figure shows two oscillating systems A, B, each attached to identical masses. All springs are identical. If A and B are performing small oscillations horizontally, what is the ratio between their oscillate frequencies? Okay, So this question needs a lot of experience to do within a short period of time. The students are supposed to understand the system, very quickly. Otherwise, it will take time. Okay. So this first diagram, is like this. No, first diagram is like this. You have a mass like this connected to this and spring, and they are serially connected. Okay. Okay. So now when a mass is connected to two things like this, you should understand when it undergoes oscillation to one side. Okay, when it moves to this side, let's say it will experience compression in this side now, and this will be stretched. Okay, so compressing ones will push it like this. The stretched one will also pull it. Okay, so you should understand that they are giving the force in the same direction. Okay, so the force acting on this oscillating mass will be the addition of these two forces. Okay, it's like this. They are connected like this, for example. Like this. If you pull it, both will push it upwards. So the total force will be addition of these two forces. Okay. So when you parallelly connect it to two spring systems like this, one system, second system, you pull it through a distance. These two will be stretched and these two will also be stretched. These two, not these two, this one will be stretched. So there will be a change of length, and according to Hooke's law, there will be some what? Force, tension. So both tension will add up and pull it upwards. So that's what you call parallel connection. This is also a parallel connection because here, when you move it to this side, these two will be compressed and this will be stretched, but it produces the force in the same direction. So it is like a parallel connection. Okay. But these two is series. These two are parallel to this. Okay. Because you're adding this and this, no? You're not adding this and this. Those will have same tension all along here. But you add this and this. Alright. So this is a serial connection. What is the resultant for series? Series connection will be like this. K1 plus K2. Parallel connection, just adding. So series, these two will produce K by 2 and this will be K. Parallel connection, just adding up, it will be 3K by 2. Okay. Second one is like all three are parallelly connected, no? So it will be 3K. Okay. So now you have the answer. You know, T is equal to 2 pi square root M over K. K M over K. And then T1 by T2 will be equal to 2 pi will be cancelled, square root. You put T1's K here because these are intrinsically proportional within root. So you put T1 3 by 2K. Above it will be what? 3K. Okay, this is gone, so it will come. A and B. A and B are performing on. I am correct, right? It's 3 by 2. This will be 3K. I am sorry. They're asking for frequencies. No, I am talking about this. No, this periodic time. No, frequencies will be the invert reciprocal of this equation. No, sorry. I missed that. I calculated it correctly, but I missed this oscillation. Okay, so F is equal to 1 over 2 pi square root will be K over M. Okay, so it is if frequency is directly proportional to square root K. Okay, sorry. So its frequency is now so FA divided by FB will be equal to square root K. K will be 3 by 2. It will be 2. Okay, so 2 will multiply. Sorry, this is 3, no? This is 3. I'm sorry. This is 3, no? I erased it, sorry. The second one was 3k and this is 3 by 2. So this isn't gone. It will be square root 1 over 2. Okay. Or 1 over square root 2. The answer is fourth one. Okay. Sorry for making some careless mistakes here. I hope you understood it. Do you understand? So you should understand. Yes, thank you. You should understand that this is a parallel connection. So it is similar to this because the forces will be given by these two systems in the same direction. So they are like addition. So here also addition. So it is similar to the parallel connection. Okay. Now another question is very good question. Okay, this 22 one is very good question. It needs a very good understanding. Okay, just copy this if you want. And in your note, please write parallel connection. Okay, you should learn to identify key points in each MCQ. That's how you learn. So in the 20th MCQ, for example, you should have written the moment of the current system will be equal to the moment of the intact system minus the deficit. Like that. For this 21st question, you should write the key point, what similar to the parallel connection. And for 22nd, yeah, let's read this question. A person with eye defect uses a spectacle with plus 2D, which means what kind of lens? Plus means it is convex lens. And you know the focal length is 50. Okay, 100 divided by 2 will be 50. You should know to convert the diopter to the power to focal length. So it's a convex lens. So why do you use a convex lens? What problem? What problem requires a convex lens? It is long-sightedness. Okay. In Tamil, I have a mnemonic. If you know Tamil, you can use. Okay. So remember this. It's a shovel. Okay. So kitta kuli thondi. Kitta kuli thondi means dig a pit nearby and make a heap far from you. Tura kuvi. Okay. So tura means kuvi. So kuvi means convex. So for far-sightedness. Okay. So they can see the far distances. Their problem is what? The near vision. Okay. So usually a person can see the shortest distance a person can see clearly is 25 centimeter. That is what you call the near point. Okay. So if you keep it at 25, yeah, I can see. But these people, they cannot see. They will have, increase in their near point. For example, somewhere here. So they will have to hold the book far from the eye than a normal person. It's 25 for me. They will hold like this and read. Okay. So they need some adjustment there. They want the object to be right from this distance because they want to look normal, right? Nobody likes to read the book like this, no? So for them to be normal, we have to arrange a facility so that they keep the object here, but their eyes see at their own near point, which is a bit elongated, which is a bit higher than the normal persons. So now they don't have to keep here. They keep at a distance where a normal person would keep. And then the image of this will be created at their own near point. And then their eyes will be, making a good, clear image. Do you understand? So please write it down. The convex lens will put the image to the person's own near point. That is not 25. Okay. That is not 25. So book at 25 centimeters from the eye. After a period of time, he had to keep the book at 30. So now what has happened? The lens is working properly, but his eyes, it is kind of deteriorating. That's why the near point is, I think it is increasing, right? So now the near point is somewhere else. So to increase the the image distance, he has to move the object also away from the lens. So lens will be somewhere here. Convex lens will be somewhere here with focal length of 50 centimeters. Okay. So now he has to move it by 5 centimeters to change the image distance. Okay. Now what is the focal length of the lens required to read the book? Again at 25 centimeters. So now eyes has undergone some problems. So now you have to change the power of the lens. Okay. The focal length is the question. Maybe you have to increase the power, right? The eye has become bad. Okay. So now you have to find out the new near point. Okay. The spectacle is for the previous near point. Now you have to find for the new near point. So now the new near point will be the new image distance when he keeps the book at 30, not 25. Now he's keeping it 30. No. So it is producing the image, for example, here. That will be the image distance. Focal length is 50. So now you use 1 over is equal to 1 over f. So what are you going to put for b? B is what you have to find out. U is positive. So you know the sign convention, right? U is positive. 1 over 30. And this will be negative because it is a convex lens, so it's negative 50. Okay, so if you do this, you will get 1 over. Okay, you do the sum. You will get V is equal to 75 centimeters. Okay, I do not waste time here. You will get this. So now this is the point where his new, okay, please note, new near point. Now he wants a normal light. He asks you, he will ask the optician to help him read from 25, keeping the things from 25. So now the new lens should keep the object kept in 25 at 75. So this will be the new U and this will be the new V. You have to find the new F. All right. Now you will use the same equation 1 over V minus 1 over 1 over F. 1 over V will be 1 over 75 minus 1 over 25 equal to 1 over F. Right. So now F will be equal to minus 37.5 centimeters. So it is a convex lens with a little bit increased power. Can you see? The focal length has decreased, means the power has increased. Okay, so it's the third answer. All right. Okay, so you should understand what happens in near vision, what happens in your short-sightedness and what happens in long-sightedness. What are the causes? Okay, there are two main types of causes. One is the thinning or thickening of the lens or elongation or shrinking of the eyeballs. Okay, so you have to draw your diagram and explain it to yourself several times, and then you will understand the concept. Always remember like this, always the purpose of a lens is to make the person's life normal. So he has to keep it at the normal distance of a normal person, but the lens will create an image in the person's own points. Okay, then the person will be able to see. Okay, like a normal person. Now 23rd, the diagram shows variation of horizontal force acting on the object kept on a horizontal rough plane with time t. The limiting friction is given as FL. Okay, can you see that? So could act on the object is FL. The best graph representing the variation of the frictional force F acting on the object with time t. Okay, so can you see that? So initially, if you move, it will be at rest. So when it is at rest, that is what you call static conditions. It's not moving. So during the static conditions, the applied force will be equal to the friction, isn't it? So initially, the graph will go like the applied force itself up to what? Up to limiting friction. Once it reaches the limiting friction, when you increase the applied force above the limiting friction, what will happen? Okay, applied force will increase, then friction will also increase. I'm drawing the graph for friction, right? Friction versus time. If you increase it, what will happen? There will be a reduction because it is shifting to kinetic. Okay, there will be reduction, and whenever it is moving, which means the force is above the limiting, means it's moving. So can you see? I have to draw both, I think. I will draw the applied force graph also. So this is the applied force and this is the limiting now. So when it increases from limiting, it comes again like this. So whenever it was above the limiting during this period, okay, there will be kinetic. Okay, it will be kinetic. When it reduces less than FL, okay, then it will stop. Okay, actually it will decelerate for a little bit of time. Okay, decelerate for a little bit of time, and then it will stop. When it is stop, once it stops, what will happen? Whatever that is acting will be the friction, because that will be again static condition. So the graph will follow the same, and then you can see it becomes above limiting again. No, so when it becomes above limiting, yeah, it will just a small reduction, and then it will continue until it is above the limiting, and then when it comes down, yeah, it will gain static conditions again, and it will go like this, static one. So the correct answer would be the fifth one. Okay, third one is, sorry, second one is similar, but in the second one, they don't show fall during the static to kinetic shifting. Okay, but in the third one, they show an unnecessary bump here also. Can you see? Third one, they show an unnecessary bump here also. So that is a totally unnecessary one, and they show an unnecessary one bump here also, the third one. No, that never happens. When an object is moving, it is kinetic. When it becomes static, there is no bump. But when statics become kinetic, there will be a small reduction. Okay. Yeah, the reverse doesn't happen. Okay, when it is shifting from kinetic to static, that will be just, okay, the flat change. Okay, now 24th, a load of weight W is at rest on a light bar AB at distance A from A. A is the wedge. AB is horizontal, the wedge on A, and the pulleys are smooth. Okay, what is the reaction at A? So it is just normal question with a difficult calculation. Okay, so have you copied this? If you want, you can copy. So one person with me. Can you please tell me a tip to remember optical instrument related thing without confusion? Yeah, you have to just understand the concepts. Okay. Yeah, I will. I can't tell. I can't give the whole explanation now, but I can tell you, if you understand the thing, you draw it. Okay. So you think about it, like short-sightedness means they can't see from far, short only. So which means a normal person can see from infinity, but their far point is only a definite distance. Okay. It's not infinity for them. So they have to see the object from infinity. So what should we do? Okay, we will help you. Like Vasa and Ikea, we are there for you. Okay, so we are there for you. So you want to see from infinity. Okay, we will take the things from infinity and keep it in your far point. Okay, another person will come. I have long-sightedness. I have to keep the book away from me. I can't read from 25 centimeters. Then we will say, okay, you keep from 25. We are there to keep it at your own near point by giving you a lens. So you can see the point where the person keeps the book is the distance, object distance, and where the person's real distances are the image distance, and you find the focal length. Okay, so whatever is given, you can find the what that is not given. Okay, so like that, you have to draw and talk about it several times, then you will understand. Okay, so it's simple theory behind all this. Physics is all about understanding. There will be only one theory, and we will make 1,000 questions. Now, all right, now there are two pulleys. I'm lazy to draw this, but no option. Okay, so this is the distance L. So this is the distance A. Okay, and then the question is the reaction here. We have no idea about the tension, and this is W. Okay, so if you are to draw the forces acting on this beam, okay, what do they call that? Bar. Okay, bar. there will be this T, and there will be the action force due to this W. So if you just keep W, it will W, but it is pulled by T, no? So here it will be W minus T, and there will be the reaction here. Okay, the reaction is the question. So first you have no idea about what is T. Okay, so you have to first find T, and then you have to do something about R. Okay, so in these questions, the basic competencies, you should be able to select a point. Okay, so now I have to find R. I don't know about R. I don't know about T also. Okay, so if I'm going to make an equation for T in terms of what is given, then I should avoid R, right? Because R is not given. R is the question. In terms of what is given, I cannot use R. Okay, I have to avoid R. So now I'm going to make an equation for T first. Okay, so what can I do? I can take moments from this point because I can cleverly avoid R. Because R is an unknown thing. Now, this will create a, about this point, what do you call that? A. Yeah, A. About A, there will be this moment. What is this? This is clockwise and this is anti-clockwise. The clockwise T into L, the distance is L and force is T, will be equal to the anti-clockwise W minus T into A. Alright. Now you have to make T a subject, and if you make it, if you do that, T will be equal to W A divided by L plus A. Okay. So this is the answer. W A by L by A is the answer for T. Okay, T is value. Now you should find R. Now you know T. Okay. So now you have to find a point to take moments. Okay. Where would you take moments from? Now you know T. You have to find R. Can't we take moments from here? Okay. So that will be the moment due to this will be equal to moment due to this. So T into this distance is L minus A. Okay. So I'm going to call the midpoint as X. So above X, I'm taking moments. So moment due to this will be T multiplied by this distance L minus A. Will be equal to R into what? A. Just A is the distance. So for T, you can put what? WA divided by L plus A. And this will be L minus A equal to R A. A gone. So R will be equal to W L minus A divided by L plus A. So the answer is the first one. Okay. Answer is the first one. Okay. Just you take the moments, find T, and then take moments, find R. That's all you do. All right. And the 25th question. What do they say? The 25th. So figure shows the path of light traveling from glass to air. Glass to air. If the critical angle between the glass air interface is C, the graph denoting the variation of deviation angle and the incident angle. The problem is here the incident angle is marked wrongly. What is mean by incident angle? Can you define incident angle for me? The normal. Incident angle is the angle that the incident ray makes with the normal. With the normal, is the definition. Here they have shown this. Can't help. Okay. I don't know. They have given like that. Okay, so that is a small mistake in this paper. Okay. Let's ignore that and understand the theory. What is deviation angle? So, okay, now tell me where is gas? Glass to air, no? This is glass and this is air. So, it will refract away from the normal like this. This is the angle of refraction. Sorry, R. So, what is actually meant by the deviation angle is angle that the incident ray makes with the refracted ray. Okay, that is the deviation. Do you understand? So, for that, the incident should be given correctly. This should be the incident, but I don't know. They have given this. Okay, they have given this. So, this will be what? 90 minus I, right? That is the angle of incidence here. So, usually we take when it's going from here to here. Can you see this line and this line? This angle and this 90 minus I are vertically opposite. 90 minus I, according to what they have given. If they had given the incident angle correctly, then we will say it is I. Okay, so there is a confusion in this question. But whatever it is, I can tell you the deviation is equal to the R. So the difference is the deviation. This is R, and you subtract this incidence. R minus 90 minus I. Okay. And D will be equal to R plus I minus 90. Okay. So when you are increasing, I mean, you start from 0 incidence here. Okay, so start from here. This will be high, no? I will be very less. And when you increase that little by taking here, I will increase and R will also increase. That when you increase I, yeah, that will happen. So this is the point where the I is equal to C. Actually, yeah, there's a problem. This I is not C, this is C, the angle with the normal. Okay. So this question is a bit, I don't have to tell that again and again, but let's do it for what is given. This is I. So this will actually be 90 minus C according to what they have given. Transition occurs not when I is equal to C, when actual incident angle is equal to C. Okay. So this should be 90 minus C if they are going to draw a graph for this. But anyway, so let's do for this. So you have to find the variation of deviation with I. Okay. So sine I divided by sine R is equal to a constant, which is what the Snell's law, that is your relative refractive index. Okay. The refractive index of glass relative to relative to air. Okay. So here the I is the actual I. So because it is going from air to gas, it will be the other way, no? The R is bigger, so sine R by sine I. Whatever it is a constant. That of course we know it is a constant. So when I increases, the R should increase. Otherwise, the ratio cannot be held, a constant. The ratio should be a constant because when you divide this by this, it's constant. So when I increases, the R will also increase. Okay. And you know how sine graphs vary, right? Sine graph is a curve. Okay. So they should vary like a curve, not a straight line. So straight line graphs, the first one, the fourth one will not come. Okay. But this will come like this. Okay. This kind of graph will come. So second one is a possibility, third one is a possibility, fifth one is a possibility. Yeah, now when it is C, which means 90 minus C here, it will undergo a total internal reflection. So at that point, initially it will undergo, when it's just equal to C, to undergo what do you call the critical refraction. Okay, it will be like this. So this is what 19 ohm, which is what you call a pi by 2 in radians. Okay, if you say this is the angle, if this is C, what is the deviation? This difference, no? This is C, so this will be pi by 2 minus C. Okay, so when it is equal to C, it will immediately go to pi by 2 minus C. Okay, so that jumping is shown. Okay, now like when it is equal to C, okay, when it is just moving, it will be pi by 2 minus C, right? When it undergoes total internal reflection, okay, it happens for the same angle, right? When you increase a little bit above C, it is just above C, it will also undergo total internal reflection. Actually, the critical point is, critical point is almost total internal reflection. That is why they don't show a shift. Okay, they don't show a difference in angle here. They straight away jump like this. Okay, so when it is C, we should also take total internal reflection. So now this is the resultant. So this will be what? This will be the deviation. Okay, deviation is here to here. So this will be the deviation, right? So now this is also C. Okay, this is also C. So the deviation angle will be what is the deviation angle? So it would have gone like this, no? So deviation is actually this. So this total is 180. If you subtract 2 C's, okay, it will be pi minus 2C. Okay, so this will be pi minus 2C. Immediately go here. Okay, now after that, for any angle, it will undergo total internal reflection. Okay, so total internal reflection looks like this, right? So this is theta, any random angle, not C now. It will have gone like this, and this is the angle of deviation. Okay, so I initially draw like this. I'm very sorry for that. I showed the angle of deviation like this. That is wrong. You have to extend it and see the difference. Okay, not this. Okay, so now this is the deviation. Okay, this is theta. This is also theta. This is total will be 180. Then you can see the deviation is equal to 180 minus 2 theta, then you will get the deviation. 180 is pi minus 2 theta. So you can see it follows minus mx plus c, right? Y is equal to minus mx plus c. So after that, it will be a straight line graph with a positive intercept and negative gradients. It will be like this. Okay. When the angle of incidence is 90, which is 5 by 2, it will not refract, it will just go like this. So the deviation will be 0. That is why at 5 by 2, it hits 0. Can you see? When it's 5 by 2, it hits 0. So the correct answer is the second answer. Okay. The last part is straight line. I have proved it here. Okay. So did you get the explanation? I understand that I was talking some contradictory points because sometimes I took this as I and sometimes I took this as I. Okay, so that is kind of a contradiction because they have marked I differently. Okay, so that is the problem. So yeah, you can't change the question. Okay, so that is all. If you have any questions, you can ask. Okay, thank you. If you have any questions, you can ask me now. Okay, thank you.